We're going to continue over the next several days with lines and linear equations and the idea of slope, but we're going to move really into an algebra unit. C2 is very much an algebra section. We're reviewing things you do in Algebra 1. If you take Algebra 2, you will do this again in Algebra 2. It's a very, very, very important topic, the idea of working with linear equations. Apparently now I can't swallow. It must be contagious. Okay. But yeah, linear equations are a pretty major topic for us, and being able to work with them and manipulate them. So everybody's attention is going to need to be up here and not like heads down or buried and stuff like that, right? I'm going to get some people's attention here. A little tap on the shoulder might be useful. There we go. Head up. Let's pay attention. All right? Pardon? Yeah, you're fine. All right. So writing linear equations. Two basic forms of linear equations that we're going to deal with. There's actually a third one as well that you may have gotten in Algebra 1. I'm not sure what they taught last year because they switched the curriculum. But standard form of linear equation looks like ax plus by equals c. Do you remember that one from Algebra 1? Yeah. Okay. What was special about a, b, and c in standard form? They had to be what? No. No. ax squared, ax plus bx plus c. Ax plus by equals c, excuse me. What was special about a, b, and c? What restrictions were on there for those numbers? A, b, and c have to be numbers. What kind of numbers do they have to be? They have to be what? Whole numbers, yes. They can't be fractions. Okay? And whichever number comes first has to be positive. So standard form is in form ax plus by equals c, where there are no fractions and the leading number is positive. Standard form is good because it's standard, but it's not a very useful form for graphing and other things. It doesn't tell us much. Standard form, we can't tell the slope. Okay? So if I have standard form, I don't know what the slope is. I don't know really where the y-intercept is. I don't know about any points on that line. It's just a standard form of the equation. But it doesn't give us a lot of useful information. So standard form is probably our least favorite form. The one you're probably most used to is slope-intercept form, y equals mx plus b. That one you probably use a lot. In y equals mx plus b, and we've already talked about this a few times because we've worked with it, the m represents the slope. My orientation is way off. I have to fix that. I can see my screen actually shifted. Did my board shift? No, my projector shifted a little bit. Okay. And B represents the y-intercept, which is a point on the line. This is the point, 0, B. And again, from a graphic representation, we know how this slope works from a graphic representation, but if this is my line, then the y-intercept is right there. That's the point 0, B. Okay? It's where it intercepts the y-axis. That's what the y-intercept is. There is a third form of the equation. I'm not sure. You have to tell me if you covered this one last year in Algebra 1 or not. And that's called point-slope form. And it looks like this. Y minus y1 equals m x minus x1. Okay? And that's useful in that it converts very quickly to slope-intercept form, but if I'm given a point on the line, x1, y1, and the slope, everything plugs in. I don't have to do like resubstitution like I do in slope-intercept form. If you want to work at slope-intercept form, you always have to plug things in, find what b is, and then resubstitute back in. And that resubstitution step is really kind of difficult for some people. This is a lot easier, and it comes from the slope equation. If I divide through, you notice I get m equals y minus y1 over x minus x1. That's the slope formula. We just didn't have the 2's and the y's, did we? So it comes from the slope formula, point slope form does. And it's actually quite an easy form to work with. So we may actually spend some time talking about that a little bit more, and then converting from point slope to slope intercept, because it's very quick to do. I distribute the m and I move the y1. It's really easy. So those are the forms of linear equations. Standard form, like we said before, a, b, and c must be whole numbers, no fractions or decimals. The leading coefficient must be positive. Converting between slope-intercept is a couple simple steps. If I want to start in slope-intercept and get the standard form, so if I'm in slope-intercept form, I need to get the standard form. The first step, we start in slope-intercept form, we move the mx to the other side of the equation, which changes the sign. That's minus mx from both sides. M is now negative. We multiply through by -1 to change the sign so it's positive. If it's positive, if it was negative over here, it's positive over here, and we're good. And then if m is a fraction, we multiply everything by the denominator to eliminate fractions. And you'll see that in practice a couple times. Working with the slope-intercept method. When we need to write the equations of lines, the first thing we always need to know is the slope of that line. In order to write the equation of a line, we always need to know two things. One, the coordinates of at least one point on that line. We got to know where one point is at least. And we need to know the slope of the line. So we need to be told the slope or the coordinates of a second point. Either one. In this case, I'm given 2 points. I'm given 2 points in the line. So the first thing we want to do is figure out what's the slope. Because when we're given 2 points, we can find slope, right? So we take y2 minus y1, 5 minus 2, okay, and x2 minus x1, -3 minus 4. 5 minus 2 is 3, -3 minus 4 is -7. So the slope of that line is -3/7. Now be careful, because 5 and 2 and 3 and 4, if we add them up, they both give us 7s. So it's real easy to make positive negative sign errors here, because you see 7 and 7 on top and bottom just by the numbers without paying attention to the signs, and you might be tempted to just write down 1 if you're not careful. Because you just see 5 and 2 and 3 and 4. But don't just see the numbers, see the symbols that go with them to avoid that mistake. Next, we substitute that information in the slope-intercept form of the equation. The slope is m. So it's y equals -3/7 x plus b. But it's still not enough. I still need to know what b is. So in third, I substitute in one of the points for the coordinates x and y. I can substitute in the 4, 2 or the -3, 5. It doesn't matter which one I choose. Which one would you like to choose? The 4, 2 or the -3, 5? -3, 5? Okay. Now, we have to be careful to substitute them in the right spots. -3 represents which coordinate, the x or the y? The x. So that's going to go in for x. What number represents the y in that point? The 5 does. Now I've got numbers in there. Now I can solve the equation. We are going to deal with some fractions. So 5 equals 3 times negative 3 is negative 9/7 plus b. If I add 9/7 to both sides, this is 35/7. 5 is. So that gives me 44/7. Okay, that's not the equation of the line, that's just the value of b. b is 44/7, and I rewrite the equation. This is the resubstitution step. Y equals m plus b. So when I do the resubstitution, I put numbers in for m and b that I've discovered, but the x and y go back to being just x and y instead of numbers. That's that resubstitution. Yeah. 5 I changed to a fraction over 7. I had to have a common denominator. I wrote 5 as something over 7. So I had a common denominator so I could add the numbers easily. And of course, I mean, your calculator will do that for you. You can go 5 plus 9/7 on your calculator, and it'll give it to you, too. We don't use a mixed number. We just use the 44/7. So that's the slope-intercept method of finding the equation of a line. And you're going to be doing that quite a bit. Whoops. Okay, the point-slope method. This is the one I want to talk about. Is actually a little bit easier. The point slope is y minus y1 equals mx minus x1. The x minus x1 are in parentheses, so we do distributive property. That's important. M is still the slope. x1, y1 is a point, and we're going to put numbers in for x1 and y1. X and y, we're never going to change from x and y. So we don't have to do this whole resubstitution deal we just did. We can just do it regularly. x1, y1 is a point in the line. M is the slope. We substitute in values and just solve for y. Get y by itself. It's usually just a couple steps. Here I've got the points 4, -2, and 7, 3. Let's find the equation of that line. Start by finding the slope. y2 minus y1, 3 minus -2. x2 minus x1, 7 minus 4. That's 5/3 is the slope. Second, pick a point. I have 2 given to me. Pick one. Which one would you like to pick? 4, 2. Or 4, -2? Okay, so we're going to pick that one. Why? Because it's what we picked. No reason why, other than we have to pick one. Now we put in the equation. So it's going to be y minus something equals m x minus something. That's our form. Y minus the y coordinate, which is -2, so y plus 2 equals m, we just found is 5/3, x minus 4. So we have to plug things in the right spots. That's important. Once they're plugged in, all we do is 2 steps usually. Distribute. Minus 20/3. And then solve for y, so subtract 2 from each side. So y equals 5/3 x. And 20/3 minus 2, it's minus 6/3 is minus 26/3. Can't we? Okay. There you go. Now again, we got kind of nasty fraction there. That's okay. It's going to happen. But it's a little bit easier, I think, than this whole, what we did before, of substituting in, solving for b, and then resubstituting again. Because that whole resubstitution thing gets messy. Point slope actually works a little more neatly. And is more convenient because we have a point and a slope. It works out nicely. let's try these 2 points. And I'll do both methods. Okay? Let's do point slope to start with. For both of these, I'm going to have to start by finding the slope of the line, right? So what's the slope of this line? 1 minus 5 over 3 minus negative 2, negative 4/5. Yes? Yeah. Okay. I'm going to pick the point 3, 1 as my point. I'm going to write it down. Y minus the y coordinate of that point equals m x minus the x coordinate of that point. Then I'm going to distribute. Negative times a negative is a positive. So I'm going to add 1 to each side. So y equals negative 4/5 x. 12/5 plus 5/5 would be 17/5. There's the equation of the line. If I use the slope-intercept method, I have the slope. So I go y equals mx plus b. My y is 1. My m is negative 4/5. My x is 3 plus b. So 1 equals negative 12/5 plus b. Add the 12/5 to each side. b is 17/5, and then I rewrite y equals slope plus b. Same equation. This one's a little less work. But if you prefer this method, there's nothing wrong with it. And this may be the one you're used to. This stuff kind of ringing bells. Remember how to do this? You did this a lot last year. Okay, you should this should not be brand new. This is just kind of a refresher. So how do we find the equation? If I'm given the equation of a line, how do I find the equation of a new line? Say, for example, I want to write the equation of a line parallel to 3x minus 4y equals 24 passing through the point 5, 6. So my situation is this. I have a known line, and I have a known point on a different line. First thing I have to do is find the slope of the given line. Because just like anything else, we always have to find the slope. Now, this is not in slope-intercept form. Three is not the slope, because it's not in slope-intercept form. In order to be the slope, it has to be in slope-intercept form. That's important. We're going to run out of time here, aren't we? Or no, we got to 11:02. We're fine. We're fine. Sorry, I was looking at fifth hour for some reason. Yes?
On the line that's given, does it have 2 points that are given?
No. I could give a bunch of different things. All I need is 1 point on my new line and the slope of the new line. Okay?
Couldn't you just take 2 points on the old line, find the distance between them?
If I found, I could find the slope between those, but I don't know any points in that old line right now. So the easiest thing to do is going to be to rearrange it for slope-intercept form. So minus 3x, negative 4y equals negative 3x plus 24. Then divide by negative 4. And you get y equals 3/4 x positive, because negative over negative is positive, minus 6. What's the slope of this line? Slope is 3/4. Okay, there's my slope. So we had to do some algebra to get there, didn't we? Now, this is why you have to take algebra before you take geometry. You need to be able to do that. Next, the slope of the second line is going to be equal to the slope or the negative reciprocal? It'll be equal if we want the line to be parallel. It'll be the negative reciprocal if we want it to be perpendicular. What do we ask for in this case? I said parallel. Might want to circle that word. So my slope has to be the same, 3/4. Now I know the slope, and I know a point on that line, 5, 6. Once I know a point and a slope, I can write the equation using either point slope or slope-intercept form. So I'm using point slope, y minus the y-coordinate equals m, x minus the x-coordinate. So y minus 6 equals 3/4 x minus 9/4, and then adding 6 to both sides. Y equals 3/4 x. Negative 9/4 plus 6. I'm not so sure about that one. Let's use my calculator. Negative 9/4 plus 6 is, and change it to a fraction, make sure we get it as a fraction, 15/4. So there's my equation. And then if I need to, it says, finally, if we need to, we translate in the standard form by moving the m to the other side, moving the mx to the other side, and multiplying by 4 to get rid of the fraction. We aren't going to do too many that have to be in standard form. Yeah. No, we'll always leave slope and things as fractions and ratios. It may not. You may have to change it from a decimal to a fraction in your calculator. Like in this calculator, you have to change it to a fraction. But that's just math 1, change to fraction. Change a decimal to a fraction is easy. It's a couple strokes on here. It's a lot of steps. These are long algebra problems. And we're going to spend like 3 days just doing this stuff. So, going to give you a bunch to practice on tonight. I want you to try your best. Practice on as many of them as you can. Come back. We'll review it more tomorrow. We'll go over it some more. Come back. We're going to go over it more probably the day after that. We're going to work on this stuff for a while, but this is a very, very critical algebra skill that is important for geometry. Okay? It is a worksheet. Yes. There's a lot of space on here for showing work. Show your work. And the last page is the answers. So you can check your work. It's really only one page front and back. The second page is your answers. Okay. Wanted to get these out just real quickly, and I'm not sure if there's anything on here that requires you to graph tonight. No, so we'll hold off on graphing line. All right. Okay. By the way, Algebra 2 has been doing the same topic with slopes and y-intercepts and stuff like that. They did it last week, so talk to your Algebra 2 friends. They might be able to help with this too. Don't have any friends? That's kind of sad. How about your Algebra 2 acquaintances?